Hello, we're going to look at working with charts that have multiple inputs. So I'm going to start off by right-clicking, going to Graphs, and selecting the first one here, Waveform Chart. Place it on the page, and then click, and let's just resize it a little bit. Then we're going to go back to the block diagram. Okay, and we're going to add something called a bundle. I'm just going to move this over to here, right click, come up to clusters, select bundle, and it's going to have two inputs going into one for the chart. The other thing I often do is go to visible items and put label so I remember the name of that. Then I'm going to add two vertical point sliders, so back to the front panel, and we're going to add those here. So go to numeric. And we're going to use the type with a slider, so that's one. And I can press the control button and create a second. Okay, and I'm going to call this one temperature. This one level. And now we have two. So if I go back to the block diagram, I'm going to bring those two into here and connect them to the bundle inputs. Now I'm going to go back to the chart, right click on the chart, and change the properties of the y-axis. So you have to make sure that you're coming up to scales, select the y-axis, turn off auto scale, make the minimum 0, and then click OK. The other thing you might want to do is change the colors of the scales, but we'll do that a little bit later. So now that we've done that, we're going to click on the bottom area here where it says time and go to properties, or we can actually just go to Y scale, style, and select the style at the bottom left. Oh, we may not have done that, so sorry, I selected the X, but you can do it both for the X and the Y. So we're doing it for that bottom scale. Now this represents 100 different samples across the screen, and if we go back to our block diagram, you'll see that my time delay is set for 100 milliseconds. Well, actually it's on the front panel. So that's 1/10 of a second. 100 samples would take 10 seconds across the screen. The other thing we might want to do is change the colors to match our level and temperature controls. So I'm going to go back to this screen, right click, properties, go to appearance, and we're going to have two different plots shown. So we can actually start off with plots. And the first plot, the top one, is connected to the temperature. I'm going to change that to temperature. And then the second plot is going to be level. Okay, and you'll see that the line for level is red. And the line for temperature, I'm going to make it blue. Right here. And then once you've done that, select OK. And we're also going to do the same thing for the indicators. I'm also going to change the level control. So if I go to properties, I can change the fill so that it's going to be red, which matches up with the chart. I do OK. Now let's just do a quick test here. So the temperature slider, I guess we have those backwards. So let's make a change again. So the temperature is going to be red, so right click, properties of the chart, and plots, temperature, we want to be red, and the level, we're going to change to blue, and let's try that one more time. So this is the level, that seems to be changing correctly. This is temperature, that seems to be changing correctly. Now let's have a look at how we can change the background color if we wanted to. So let's right click, go to create, property nodes, and you'll probably find one that says plot area, colors, and let's choose background. So that puts this property node here. Now it's set up so that it's going to get information from the property node, but we want to change it to a write. So we write something to the property node, and then we're going to do create constant. And to create the constant, you come down here, constant, and it already has a color there. I could change it a little bit. Let's say I wanted it not so dark, and that's changed that color. And that's going to happen every time we start up since it's outside the loop. The next thing we'll want to do, and that has to mean that we go back to here, right click, create a property node. We're going to scroll all the way down to the bottom to history data. Comes out here, and same thing, change to a write. Change to write, and then we're going to right click on here, and the same thing, create constant. What that does is every time we run the program, it's going to start the chart at 0. So if I click run, and notice the background changed as well. So maybe those are not good colors. Maybe I need to change the background. So let's do that quickly. So window, show block diagram. I'm going to make that black again. So you want to make sure that this changes to a little hand pointer. And then let's go black and run that again. Go to the front panel. And I think that's okay. And so the level is the red slider. The blue is the temperature is the blue slider. Here we can change our time, but notice that when I run the program, it takes about 2 seconds, 3 seconds. It'll take about 10 seconds to start filling that chart completely because of our 100 millisecond delay. All right, I think that concludes this example of working with charts. Let's begin by creating a 2-channel input for analog signals that will measure the thermistor voltage and the supply voltage. So the first thing I must do within the block diagram is right click, go to Express, and then you can select Input, DAC Assist, place it somewhere on the page, wait for this to complete, and then we're going to measure an analog input. So we need to select analog input, voltage. We're going to be working with 2 channels, so you can press on the control button and then say finish. And then what we're going to do is do some basic tests, but we want to have our range be at a minimum of 0 volts and a maximum of 5 volts for this particular example. So now we have that set up, and we can change the names here so that they make a little bit more sense for our application. So right click, say rename, and well, let's just verify this before changing a name. I'm going to do a little test by clicking on run, and I'm looking at these 2 channels here, and the first one is called voltage 0, and the order of that is the first, or 0, and it seems to be the supply voltage. So that's why I'm now going to rename that supply. And I can just backspace and hit supply. Okay, and then I'm going to put this to thermistor voltage. Or just V thermistor will work. Okay, I have that now. So you can see that the supply is around 4.5, the thermistor is about 2, which makes sense for the temperature that we're at. So once we've done that, and just make sure you remember that the supply is channel 0, we can click OK, and that's going to create our DAC assist. And we'll just wait for that to complete. Okay, it's completed. Now we're going to create 2 channels, and we're going to go to Express, and right here, Express and Signal Manipulation, and we're going to click on From Dynamic Data Type, and we're going to click the single scalar, and we're going to start with channel 0. Okay, that's fine. And I'm just going to create a second one of these by hitting the control key and sliding this down. But I want to double check that it's also a single scalar, but this is going to be on channel 1. Okay, so I'm going to attach this to this and the second one to here. And then I'm just going to put an indicator at the output of each of those. So create indicator. And since this is channel 0, that was supposed to represent the supply. And another one here. So just at the end of this, do create indicator. And I believe that was the thermistor voltage. Okay, so I've got both of those, and we can just test it out. So I actually have it connected to my hardware. I'm going to click on Run, go to Front Panel, and this is making sense. So you just want to double check that that's the thermistor reading and that's the supply reading, so it's fine. Okay, now we'll go back to the block diagram, and we're going to create a formula node. So to do that, you go to Structures and Formula Node. I'm going to put it on the page and drag it so it's big enough. We can make it smaller afterwards. And we're going to add 2 inputs. Right click, add input. And I'm going to call this voltage supply. And I'm going to create another one, add input. And I'm going to call this one voltage thermistor. And I'm also going to create an output and call that right here resistance. Okay, so it looks like I have everything I need. Now I want to add an equation. So it's going to be voltage supply minus voltage thermistor. And I have to add resistance. And case is important here. I'm going to put brackets around these so they're done first. And then I'm going to divide by voltage thermistor divided by 10,000. Make sure you have the right number of zeros, brackets, and then semicolon. And you can even add your name here. And the date, October 26th, 2025. Okay, and even another comment to calculate resistance. Okay, and then I'm going to add maybe an indicator out here. Create an indicator, change it to resistance, so it seems to make sense. I'm going to add this to here and this down to here. So I think I have everything I need to do a basic test. So let's see if that works. So run it, go to Windows. Okay, and it's telling me that my resistance is about 10.6K with these voltages. So I think that's probably okay to be able to move on to the next step. Hello, let's continue the Lab 4 demonstration, and we're going to start off by adding something called scaling and mapping, which is going to use linear interpolation to convert the resistance to a temperature. So to do that, we have to right click, go to Express and Arithmetic and Math, and you'll see the scale and map, and we'll just place it here. Now we're going to have to open it up, and we're going to use interpolated. So we have to define a particular table, and that should be supplied on Brightspace. I have it saved on my machine, so I'll go to Define Table and then Load Data. And I should have a file up here called, it's going to be in my Chem 8302 under Labs, under Lab 4. And this is the file right here. I created this in fall 2022. So you open this up, And what this data represents is the information from the data sheet that shows every 5-degree increments. For example, at 25 degrees Celsius, you'll have a resistance of 10K. At 60 degrees, 2.5. At 10 degrees, 19K. So coming into this function is resistance, and leaving it is temperature. So once we've done that, let's say OK, and OK to that. And now we should be able to take this signal coming in and connect it to resistance. That's our input. Let's move it over a little bit, and our output is going to be temperature. And we can test it out in just a second. There we go. Okay, so now if I want to run it, and I actually have a thermistor connected, and I go to the front panel, I'm seeing that the resistance is about 10K and the temperature is about 23.6. So it makes sense for what I expected. Let's go back to the block diagram, and then we'll add the next component. Our next component is the smoothing filter. So to get that, I right click, go to Express, and it'll be under Signal Analysis, Filter. So put that on the page. And since it's an Express VI, I have to make some changes. So the filtering type is smoothing. I want to select moving, average, rectangular, and change the half width to 10. That's an amount that gives you an appropriate amount of filtering without having too much lag. So once we've selected all of that, select OK. Okay, and then I'm going to connect the input of that to the temperature. Okay, and the output is going to be filtered temperature. Now, one of the things that I just discovered that you can do is you can right click on the wire and click on Insert, Signal Manipulation Palette, and click on From DDT, Dynamic Data Type, select Single Scalar, and then OK. And it converts the dynamic data type to a single scalar. And I can actually do the same thing here. Insert, Signal Manipulation, from Dynamic Data Type, Single Scalar, OK. And I just want to make sure that, so if you notice that this doesn't seem to be coming from the right hand side, which is the output, you can click on the wire and say Clean Up Wire. Now that makes a little bit more sense. So we have that, and I would have already had these variables created, and they're connected to a local variable. It's going to go to a waveform chart. So let's just see what happens when we run this program. So we're going to go to Show Front Panel. And so this bottom chart represents the filtered output, and the top part the non-filtered. So I'm just gonna, with my fingers, heat up the thermistor. Okay, and that's changing a little bit. It's not too noisy, and it causes the output to change properly. So I have the temperature and the filtered temperature. They all seem to be doing what I expected. In this next part, I'm going to add a second formula node. So right click, we have to stop first. Right click, Structures, Formula Node. I have to drag it to give it some space. And most of the time I like to add a caption above this, or a label, telling me that it's a formula node. I might need to make this a little bit bigger because I need a feedback node here. I'm going to add that right away. So the feedback node is right click, Structures, and down here is the feedback node. I put it in place, and it's kind of available for when I need it a little bit later on. So the next thing I'm going to do is in the formula node, I'm going to add 4 different inputs. So basically just on that edge, we add an input. And the first one is going to be set point. The next is going to be deadband. So add input, deadband, and add another input. It's going to be filtered temperature. So FT, and then heater output. So this is going to be for the feedback. And so I'm actually going to add a heater output here. Heater output, and I'm going to add upper threshold and lower threshold. Oops. So on this border, add output, upper threshold, and then lower threshold, and then I'm going to connect them to the variable indicators. Lower threshold. And I'm going to connect them. There we go. And I can't connect this numeric output directly, so I have to add something called not equal to 0. And that's in the comparison menu right here. I'm going to put it here. I'm going to put a label so I know what that's for, and it's going to connect this binary output to this numeric output. Now, since I'm going to be latching my heater output, I need to have this feedback. And to connect those, you'll see there's a connection point. I'm going to connect it to this numeric output. This feedback node is going to go to the heater output, which is actually an input. And then I'm going to add a constant right here. There's a connection point, a little bit tricky to get to, and create constant. And I want it to be 0. So that when the program starts, this HO is initially going to be equal to 0. So I also have to connect the set point, the deadband, and the filtered temperature. So I can create a local variable, place it here. So right now it's trying to write something to it because the connection point is on the left. I want to change it to a read. I have to right click, change to a read. Now the arrow is pointing on the right, so I can connect this. And then you got to make sure you have this little pointing finger, and then select the variable filtered temperature, because that's what we want to work with in our program. So we have all of those things now. So now it's time to write some code. Okay, we're ready to write the code. I'm going to add line numbers, and you do that by going to visible items, line numbers. Kind of handy when you're troubleshooting. So I'm going to start off with upper threshold. Oops, select that line. Upper threshold is equal to the set point plus the deadband divided by 2. Don't forget the semicolon. And the lower threshold is equal to the set point minus deadband divided by 2, semicolon. And then we're going to say if the filtered temperature is greater than the upper threshold, in that case we want to have the heater output equal to 1. So heater output is going to equal to 1. If the filtered temperature is less than the lower threshold, that's when we want to have the heater output equal to I think it's actually the other way around. So that if the filtered temperature is less than the lower threshold, it means it's too cold. So we want the heater output to equal 1. And we'll change this to 0. Okay, and I think that's it. Let's just check if we have any errors. It seems to be okay. So let's go to the front panel and have a look at how things are working. So here's our front panel. I'm going to set the deadband to, the set point to 28 degrees. Okay, and based on our program, it's going to make the upper threshold 29 and the lower threshold 27. So right now, the filter temperature is 24 degrees. So we're lower than the lower threshold, so the heater should be on, and it is. But now I'm just going to manually heat up my thermistor. And when it goes above 29 degrees, I'm going to watch this filter temperature. As soon as it goes above 29, I would have expected that output to go off, but it didn't. So let's find out why. I took a little bit of time to discover the problem, and I believe it's that in this second if statement, I had a semicolon here, which I should not have had. So I'll erase that, run it again, do it to my front panel. And right now my temperature is above 29 degrees, so the heater should be off. So I'm just going to wait for the heat to go below 27 degrees. That might take a little bit of time, so I'll pause. So now our heater output came on because the temperature is below 27. So I'll heat up my thermistor to get it to go over 29 this time. And it should turn it off. All right, seems to work as expected now. All right, in this continued section, we're going to add some extra features to just make the data look a little bit better. So the first thing I'm going to do is modify some of these numbers. For example, this represents the supply voltage and the thermistor voltage, and it's to too many digits of precision. So what I will do here is I'm going to select both of these and then right click, go to Properties, Display Format. Automatic formatting is fine. So we're just going to make this 2 digits of precision. Turn off this hide trailing zeros and change to digits of precision. So now these two boxes seem to be more appropriate. And for temperature, 1 degree of precision is fine. So let's try selecting a few things here. So use the Shift key. The next box, we'll do it to this box, to this box, and to upper and lower threshold. So we have 1, 2, 3, 4, 6 different items. I believe you'd only have to select one of them. Go to Properties, Display Format, leave it automatic, 1 digit of precision, and digits of precision, and I think we're okay. Okay, so it's done it to temperature, filter temperature, upper and lower threshold. Didn't seem to do it to these two, but let's, it might have done it to these numbers instead of what's in this box. But we're gonna do some other things. Now the next one we're going to look at is working with some decorations. So if you right click here, go to Decorations, I'm going to select this horizontal button box, and I'm going to put it in this area, drag it a little bit bigger, and then once I've done that, you want to select the box and you want to see this little marquee ring floating around the box. Then right click, and then right click and go to up to here, and we want to bring that box to the back, so move it to the back. And you'll notice if I move the box around, it doesn't include what's underneath, but I can now go to this, and then if we go to group, it'll group whatever is inside that box. Now if this box moves around, it stays with the items. And I can do the same thing here. I can add a box under Decorations. Let's just try a different style. Put it here. And all these things are kind of common, so make sure that the box is highlighted, so it has to have that marquee floating around it, and then you can do move to back, and then we can also group it. We can do it at the same time, maybe not. You have to do this to group it, and then up to here to group. The other thing you might find handy is sometimes you'll have 2 different controls and they're not vertically or horizontally positioned the way that you might want. So one of the things that you can do is group them together, and then there's an alignment, and I want them to be all aligned at the bottom. So this will take care of that. Okay. The other thing you might want to do is when you're operating these controls, and let's say I move this up and down. Well, it only seems to be moving a whole digit at a time. So that might be because of the data we're using. So let's look at the block diagram. And I'm looking at the temperature, and it's a double precision. So that shouldn't be the reason it's doing that. Let's go back to the front panel. And I'm going to click on this box and go to properties and look at something. Well, this is what we didn't get to change before. Let's see if we can do that now. So 1 digit of precision for temperature. These digits of precision. Select OK. I'm going to try running this now. And yeah, I'm able to go up and down, but notice I'm going above 7 and that I can go below 3. So let's change things so that doesn't happen. Maybe I only want to change by 0.2 degrees at a time. So to fix that issue, we're going to click on this box and go to properties, data entry, and we're going to turn off default, and I want the minimum to be 0, and I want the maximum to be 2, and I want to increment by 0.2. We also have to edit this, so if it goes out of the range, coarse means make it equal to this value, kind of force it to, and this is forced, and this is going to force to the nearest. Okay, so let's see what happens when we do this. So run the program, and now notice that it's going up only by 2 at a time. It only goes to a maximum of 2 and a minimum of 0, just like what we wanted. I think this slider will do the same thing. Okay, and I can even change it. Let's say I want it to be 0.2 degrees. So properties, display format, data entry, we were there. We can make this 0.25. So that way we only change by 1/4 of a degree. Okay. And let's do the same thing here while we're here. Properties, data entry, turn off the default. Minimum is 0. Maximum is 40, and we want to go up by 0.25, and we're going to ignore this and go to change it to coarse to nearest. Okay, and we can even make this a little bit bigger scale. Same thing here. Let's try to make them the same can. Now we run it. So now when I change this, notice that I'm only going up by 0.25. Now if you notice this scale, it seems to always show the 0, but this one doesn't. Sometimes when you get to 0, it's hidden. So let's fix this up. And now we have properties. I think that was in display format. Yeah, we didn't change this, so down to 1, digits of precision. Okay, test it. Yeah, notice now that the temperature is just moving. It's still not quite right. I think we wanted 0.25. Yeah, it seems to be going by well, it could be okay because we just don't have the extra digit of precision. But let me just double check that. And it's properties, data entry. These all seem to be set up okay. Let's just check this number. Properties, display format, digit of precision. Maybe let's add 2 here so we actually see that. 25.3. 25.3, we're too cold. Okay. If we were to heat up the thermistor, let's give that a try. Heat it above 31. That's going to go off our scale, but that's fine. We're going to see it up here in our filtered temperature. As soon as we go over 31, that turned off. So everything seems to be working okay. One more thing to show is that sometimes you want the text to be bigger, bolder, a different size. So I'm going to select this variable and I'm going to go up to here. This is called text settings. And I'm going to change the size to 24. Then you'll notice that it went larger. I can change the color by going up to here. Unfortunately, you can only change one thing at a time, which I've never liked, but that's the way LabViEW is. Style, I'm going to make it bold. So sometimes you'll need a character to be a little bit larger, and this is what I've done here. All right, I think that's all for this particular example.